Good morning, everybody, and welcome back to Next Door NetAdmin. Earlier this week, I had to work an overnight job. Started at 5 p.m. after a full day of work, and I didn't get home until 6 a.m. the next morning. I had intended to walk you all through it while I was there, but it didn't exactly go according to plan. In fairness, long, unpredictable hours and unexpected difficulties are just a normal part of life for a network administrator. So there's nothing unusual or especially notable about any of that. But it does make it harder for me to show you what I was doing in a relatively clean and understandable fashion. So let's go through it all now, starting with what was the job? The job in this case was a P2V, or a physical to virtual conversion, taking a physical desktop and cloning it into a virtual machine. I'm going to apologize up front because there's a lot of acronyms involved in this process. I'll explain each and every one of them, and don't feel bad if you feel like you're losing track of everything. This isn't a task for beginners, but it'll give you an idea of what it involves. I'm going to be demonstrating the process using two virtual machines for simplicity's sake, but the steps we'll be following are the same, whether your source machine is physical or virtual. Let's start by taking stock of what we need to do this. We need a source machine, some interim storage, a WinPE boot disk, and a destination machine. The interim storage can be anything that doesn't belong to the source or destination machines. It could be a USB drive if you have one big enough, but I usually use a file server on the network. The WinPE boot disk. What's that? Windows PE, or Pre-Installation Environment, is a stripped-down copy of Windows intended to allow technicians to run some basic commands and utilities for working with a system without running a full copy of Windows from the hard drive. This is important to us because it means we can make sure our source and destination machines are consistent the whole time. There's nothing running which could change files in the background while we're trying to copy them. In this case, I created my Windows PE boot disk by using the Windows 2022 ADK, or Assessment and Deployment Kit. I'm not going to go into the full process right now. It's enough for the purposes of this video to just let you know how I got it, so that you can dig into it yourself if you want. I should note here that the process I'm going to demonstrate is only one way to make this conversion happen. There are other tools out there, including some very expensive tools from Microsoft, that aim to make this process easier or more convenient. But the tools we're going to be using today are free, and they come from Microsoft in every copy of Windows. If you know how to use them, you don't really have to purchase anything else. The exact tools we're going to be using today will be diskpart, DISM, and BCD boot. Diskpart is the disk partitioner. DISM is the deployment image servicing and maintenance tool. And BCD boot allows us to create a boot configuration data store, or BCD, which will allow us to boot the new system. When we make a copy of the source system using DISM, we'll be storing it in a WIM file. That's a Windows image file. WIM files have actually been used as Microsoft's standard format for providing Windows installations since the time of Windows Vista. And all the tools I'll be showing you today have used mostly the same process since Windows 8. So, lastly, some assumptions I'm taking for granted, but which should be mentioned out loud. I'm assuming the source machine is capable of being booted via UEFI. The Unified Extensible Firmware Interface is the modern replacement to the old BIOS, or Basic Input-Output System. If you have a boot menu on a physical machine, you may see an option for Legacy Boot. That's a BIOS interface provided by the CSM, or Compatibility Support Module. In Hyper-V, your generation of virtual machine will determine which boot interface you use. A Generation 1 virtual machine will use BIOS, and a Generation 2 virtual machine will use UEFI. You can theoretically migrate a system in either direction between BIOS and UEFI, with some important differences in partitioning and boot file creation. But for today, we're going to stick with UEFI and Generation 2 VMs for both source and destination. Got all that? We all good? All right, let's get going. We're starting off here in Hyper-V Manager. We have both of our virtual machines here, source and destination. We can see that we've got an important file on the desktop here. This will be our stand-in for all the applications and data you have on the original system. The first step is to safely shut down your source machine. So let's do that now. While that shuts down, let's check the settings here. My Windows PE boot disk is loaded into both of these as an ISO file. But you can always use other tools to put your ISO file onto a USB stick if you're working with a physical machine. Most physical machines have an option to temporarily choose a different boot device, and you should use that option to boot from your USB stick or DVD rather than changing the boot order. But in a virtual environment, I'm going to need to temporarily change the boot order here. If you do that, make sure you put the Windows Boot Manager back at the top of the boot order after you're done. Some machines will fail to boot correctly if you have the Windows Boot Manager present but not at the top. Just going to move this to the bottom so that I have the maximum amount of time available to boot from the DVD drive. For now, let's go ahead and turn our source machine back on again, making sure to boot from the virtual DVD drive when prompted. In a virtual environment, you might even need to hit the reset button on the virtual machine to get another chance at hitting the keyboard at the right time, if you didn't get it the first time. So long as Windows itself hasn't started booting, that should be okay. If Windows does boot up fully, just shut it down and give it another go. When Windows PE boots up here, you see that I've added a power configuration command that runs automatically. This command sets Windows PE into maximum performance mode. By default, it would run in balanced performance mode, and that makes a surprising difference to how quickly your disk operations run. The next thing we want to do is confirm that we have networking available. We can make use of the standard ipconfig command here to confirm that we have an IP address. We do, so let's go ahead and connect our network share. There we go. Now let's go ahead and load up diskpart. There's no guarantee that your disk drives will have the same drive letters assigned under Windows PE as they do under normal Windows, so we want to double check that we're working with the correct drive. Diskpart can be a little slower to load under Windows PE than under normal Windows, so make sure to give it all the time it needs. You can use the command list volume to show the list of volumes detected here. We can see the drive letters assigned, and this looks to be the right drive. Volume 1, drive letter C. Let's exit diskpart and check the volume to be sure. That looks right to me. Now we want to create our image using DISM. We're going to capture an image to an image file on our network drive. From this directory We're going to add a name for our later reference. And a description so we can give more details about what it is. We can compress the image as well. You can choose max, fast, or none here. I usually use max because even though you spend more time doing the compression, you usually save more time by the fact that you'll transfer less data over the network when you restore the image to the destination machine. We do want to enable checking the integrity of the WIM file. Gotta make sure I spell it right though, or else it won't work. And we'll want to verify that the contents of the WIM and the drive match. Lastly, the scratch directory. The scratch directory is a very important thing to add when you're working under Windows PE. If you're working in normal Windows, you should have lots of temporary space on disk. But in Windows PE, you have a maximum 2 gigabytes of RAM disk to use as temporary space, and DISM will usually run out of space during the process. That would cause your capture to fail. The scratch dir option allows us to specify a directory on the network share to be used for temporary space. Let's go ahead and review the command just to be sure we spelled everything right. Again, if we don't spell it right, it doesn't work. Yep, that looks good. Let's do it. This will take some time to run, so let's go have lunch, and we'll come back once it's done. Right, so DISM has finished capturing the image. Let's shut down our source machine now using WPE util shutdown. And that's it. Now we can switch over to the destination machine. First, let's take a look at the settings. You can see that we don't have a Windows Boot Manager entry because nothing's been installed here yet. So we can go ahead and just turn it on. Again, we're going to boot into Windows PE, confirm network connectivity, and then attach our network drive. It'll just take a few minutes to bring it up. Perhaps not a few minutes, that's an exaggeration. There we are. Now we can check for connectivity. We've got it. And we've mapped the network drive. Since we're putting this on a blank disk, we'll need to create the partition structure for this manually. Again, we'll go into diskpart. If you're doing this from a USB stick, you may have multiple drives to choose from, and we don't want to erase your USB stick while we're doing this. We want to make sure that the image goes onto the normal hard drive. So let's list disk and review the disks we have. We only have one here, so let's select disk 0. I know it's blank, but I will always clean the disk to make absolutely sure that everything is starting from scratch. Because this is a Generation 2 virtual machine and it boots using UEFI, we'll want to partition this as a GPT disk. That stands for GUID partition table. So let's convert GPT. The first partition we create will be the EFI partition. It doesn't have to be big, just 100 megabytes. Let's format it with a FAT32 file system, which is the standard for an EFI partition. I'll also usually label it system just to make sure I know that this is the partition we're booting from. Next, we'll create the MSR partition. That's the Microsoft Reserved partition, and it can be just 16 megabytes in size. It doesn't need to be formatted, it just needs to be present. Lastly, we'll create a primary partition using the remainder of the disk. This will be formatted using the standard NTFS file system, and we'll specify a quick format to speed things up. Let's assign this as the S drive and exit diskpart. Now we're going to use DISM again. Let's start by taking a look at the image information. We can see that the image has the name and description that we said earlier, and we can see how large the image is. Note the index number here. A WIM file can hold multiple images, so you want to know the index that you want to apply. We're going to apply the image from the image file on our network drive to this directory. We're going to use the index of our desired image. We're going to check the integrity of the WIM file before we apply it and verify the results when we're done. We don't need a scratch directory for decompression, so let's go ahead and let that run now. This takes much less time than capturing the image, but it's still enough time to go get a coffee. Our image has finished applying, so we're done, right? Not quite. Remember that we don't have a Windows Boot Manager created on the destination virtual machine yet? We're going to switch to the restored system's Windows/System32 directory. And we're going to run bcd boot. We need to tell it which Windows installation we want to boot, and that's the S Windows installation. The Windows Boot Manager entry will now be created, just like that, and when the system boots, it will assign itself as the C drive. We only used S because that's the letter we gave it under Windows PE to make sure we didn't collide with any other drive letters, like a USB stick if you were booting from that. Now we can WPE util reboot, and we will boot into our restored system. While that boots, I'm just going to go back into the settings to show you that we do now have the Windows Boot Manager as the first entry in our boot list, just as it should be. We'll give the virtual machine a couple of moments to boot up here. There we are. Let's just log in and make sure that we still have our important file. And we do. There it is. Let's make sure the contents are good. And there they are. Perfect. We're all done. And that's all there is to it, right? I know, it's a lot to remember, but fortunately, you don't have to. That's why I'm here. Hope you enjoyed that look at one of my jobs. I am your next door net admin. Thanks for joining me.